Chapter number 9, Chemical Equilibrium. When we think of the term equilibrium, the first word that usually comes to mind is balance. However, the balance may be achieved in a variety of ways. Topic is dynamic equilibrium. Objective students will be able to define chemical equilibrium in terms of a reversible reaction. Now about how to establishment of equilibrium state through graph. Chemical equilibrium state: when the rate of the forward reaction take place at the rate of a reverse reaction, the composition of the reaction mixture remains constant. Two possibilities: static equilibrium and dynamic equilibrium. Static equilibrium, this happens mostly in physical phenomena. For example, a building remains standing rather than falling down because all the forces acting on it are balanced. This is an example of static equilibrium. Dynamic equilibrium: when the reaction does not stop. Only the rate of the forward and reverse reaction become equal to each other but take place in opposite direction is called dynamic equilibrium. Another definition of dynamic equilibrium in easy words: the stage at which the two rates, rate of forward and rate of reverse reaction, will become equal to each other is called dynamic equilibrium state. For example, H2 plus I2 is converted into 2HI. 2HI is converted into H2 and I2. They establish a equilibrium state. 50% reactant and 50% products are formed. Rate of forward reaction is equal to the rate of a reverse reaction. In a reversible reaction, dynamic equilibrium is established before the completion of a reaction. It is represented by a graph. Graph is drawn between x-axis and y-axis. On x-axis time shows and the y-axis reaction rate. This is a forward reaction and this is a reverse or a backward reaction. At the beginning, in the beginning, as the concentration of the reactant is high, concentration of the reactant is higher than that of the product, the rate of the forward reaction is faster than the reverse reaction. At the beginning, rate of the forward reaction is faster than the rate of the reverse reaction. It means reactant is converted into product and product is formed is slowly. As the reaction proceeds, the concentration of the reactant will gradually decreases while that of the product will increases. Consequently, the rate of the forward reaction will go on decreasing. Forward reaction will go on decreasing and the reverse reaction will go on increasing. And ultimately, the two rates will become equal to each other. Thus, the equilibrium will be set up and concentration of various species H2 and I2 and HI become constant. It is represented as this one. It is represented as H2 and I2 is converted into HI and the reversible reaction is equal to the forward reaction is equal to the reversible reaction. Macroscopic characteristics of the forward and reverse reactions. It is a reaction in which reactants react to form products. It means H2 and I2 is react to form a product 2HI. In a reverse reaction, it is a reaction in which product react to produce reactants. It means the product is formed in a forward reaction 2HI. 2HI is converted into hydrogen gas and iodine gas. It takes place from left to right. It means this arrow. And it takes place from right to left. At initial stage, The rate of forward reaction is very fast, shown in a graph. In the beginning, the rate of reverse reaction is negligible. It slows down gradually, it speeds up gradually. Most important short question. Home task. How is dynamic equilibrium established? Difference between forward and reverse reaction. Define the chemical equilibrium.